3:45 in the morning. The central Persian Gulf. USS Mason was already at general quarters. Passive sensors had picked up a thermal bloom from the Iranian coast that should not have been there. The crew did not yet know if this was a test, a mistake, or the beginning of a regional war. The air outside the hull was thick with humidity and the heavy smell of salt, but inside the Combat Information Center, the atmosphere was refrigerated and clinical. Blue light from the Aegis consoles reflected off the faces of 24 sailors, their eyes locked on glowing glass displays. The ship, a destroyer designated DDG-87, was one of the most capable platforms in the United States Navy. It sat like a silent sentinel 40 miles off the coast of the United Arab Emirates. For the last 72 hours, intelligence reports from the Indo-Pacific Command had suggested an increased state of readiness among Iranian missile batteries near Bandar Abbas. Now, those reports were no longer theoretical. The tactical air officer spoke with a voice that was practiced and steady, devoid of the adrenaline that was surely pumping through his system. He reported a multiple launch event. 4 distinct thermal signatures had been detected by a space-based infrared system satellite, and that data was being fed directly into the Mason's combat system via Link 16. Seconds later, the ship's own ANSPY-6 radar suite roared to life, punching through the humid night air with high-energy electromagnetic pulses. On the large screen at the front of the compartment, 4 yellow diamonds appeared. They were rising rapidly. These were not slow-moving cruise missiles or low-flying drones. These were ballistic threats, lofted into the upper atmosphere, arcing toward the carrier strike group further south. The speed was already staggering. The track data indicated the targets were accelerating through Mach 3 and climbing toward the edge of space. Bridge. Combat. We have 4 positive tracks. Designated Bravo India 001 through 004, the tactical air officer announced over the internal circuit. Projected impact points are within 15 miles of the high-value asset, requesting permission to engage with the Standard Missile 6 battery. The commanding officer of the USS Mason stood at the center of the room, his arms crossed. He looked at the data. The range was 140 miles and closing. The missiles were Iranian-made Khalij Fars anti-ship ballistic missiles. They were designed to strike moving targets at sea using terminal seekers. If they were allowed to reach the peak of their trajectory, they would begin a terminal dive at speeds exceeding 5 times the speed of sound. At that velocity, even a non-explosive kinetic hit would be enough to cripple an aircraft carrier. Execute the engagement, the commanding officer said. Batteries released. Fire for effect. In the forward and aft sections of the ship, the heavy steel hatches of the Mark 41 vertical launch system began to cycle. Each hatch weighed hundreds of pounds, but they moved with the precision of a Swiss watch. Deep inside the armored cells, the first 4 Standard Missile 6 interceptors received their final targeting uploads. These were the most advanced interceptors in the American inventory, capable of engaging both traditional aircraft and ballistic threats in the terminal phase. The ship shuddered. It was not a hit, but the violent release of energy. As the first interceptor ignited, a pillar of white-hot flame erupted from the forward deck, illuminating the entire superstructure of the destroyer in a hellish orange glow. The sound was a continuous, deafening roar that vibrated through the steel hull and into the boots of every sailor on board. The smell of burning solid rocket propellant, sharp and chemical, was sucked into the ventilation system. 1 second later, a second missile followed, then a third, then a fourth. Each Standard Missile 6 cleared the deck in less than half a second, trailing a thick column of white smoke that hung in the still, humid air. The interceptors pulled a sharp gravity-defying turn, their nose cones pointing toward the stars. They were chasing targets they could not yet see, with their own seekers, guided instead by the powerful radar beams of the Mason. Outside on the wings of the bridge, the lookouts watched the 4 streaks of light recede into the blackness. The missiles looked like falling stars moving in reverse. Within 10 seconds, they were gone, leaving only the fading rumble of their engines and the lingering scent of cordite and ozone. Back in the Combat Information Center, the countdown began. The interceptors were traveling at over 3,000 miles per hour. The Iranian missiles were coming down. The two groups of objects were on a collision course at a closing speed of nearly 10,000 feet per second. In the vacuum of the high atmosphere, there would be no sound. There would only be the math of the Aegis system and the cold reality of kinetic energy. Time to intercept. 45 seconds, the radar operator called out. The room went silent. The only sound was the low hum of the cooling fans for the supercomputers. Every person in that room knew that the next minute would determine the fate of thousands of their comrades on the carrier just over the horizon. The shield had been thrown. Now, they waited to see if it would hold. The presence of the United States Navy in the Persian Gulf was not a matter of choice, but a requirement of global energy security. Headquartered in Manama, Bahrain, the Fifth Fleet commanded a force of over 21,000 sailors and Marines dedicated to keeping the sea lanes open. The mission was centered on the Strait of Hormuz, a narrow waterway where 20% of the world's petroleum passed every single day. In the spring of 2026, the fragile stability of the region had begun to fracture under the weight of renewed sanctions and a series of unclaimed drone attacks. The air in the Gulf was a heavy, stagnant weight of 95-degree heat and nearly absolute humidity that clung to the gray steel of every hull. For the 3 weeks leading up to the engagement, intelligence had been flashing red across every secure terminal in the Indo-Pacific Command. The National Security Agency had intercepted encrypted bursts of data between the Islamic Revolutionary Guard Corps and their coastal missile batteries near Bandar Abbas. These were not the standard training cycles observed during the previous year, but a systematic preparation for a synchronized multi-axis strike. The United States had responded by moving Carrier Strike Group 2 into the North Arabian Sea, keeping the high-value assets just outside the reach of land-based cruise missiles. USS Mason had been assigned to Picket Station Alpha, a position located at 26 degrees north and 54 degrees east. Its specific role was to serve as the forward eyes and ears of the strike group, using its ANSPY-6 radar to look deep into Iranian territory. The destroyer was a lone shield, positioned so that any missile launch toward the carrier would have to pass through its engagement envelope first. Every sailor on board understood the geometry of the threat. They were the first line of defense, and if they failed, the carrier would have only seconds to react. The escalation had reached a breaking point 48 hours earlier, when a Panamanian-flagged tanker was seized by fast attack craft in international waters. Diplomatic cables had gone unanswered, and the rhetoric from Tehran had shifted, from defiance to an explicit threat of closing the strait entirely. The deployment of the Khalij Fars missiles was the ultimate expression of that threat, a weapon designed specifically to challenge American naval dominance in confined waters. These were flight-tested systems, capable of hitting a maneuvering ship with a half-ton high-explosive warhead at hypersonic speeds. Inside the headquarters of the Fifth Fleet, the tension was a physical presence that could be felt in the rapid-fire exchange of tactical data. The theater commanders were not just watching the USS Mason. They were coordinating a massive net of sensors stretching from space down to the seabed. Airborne early warning aircraft, specifically the E-2 Charlie Hawkeye, circled at 30,000 feet, providing a top-down view of the entire battlespace. This was a professional, multi-layered response to a calculated provocation, a chess match where the pieces were made of steel and the stakes were measured in thousands of lives. The Iranian strategy relied on saturation, the belief that any defense could be overwhelmed if enough missiles were fired at the same time. By launching a 4-missile salvo, they were testing the response time and the magazine depth of the American destroyer on station. It was a cold calculation of attrition, designed to see how many million-dollar interceptors the United States was willing to expend to protect a single point on the map. But the Aegis combat system was designed for exactly this scenario, a machine built to process 1,000 variables a second without the interference of fear. As the Standard Missile 6 interceptors climbed through 20,000 meters, the data link between the ship and the missiles remained solid. The Mason was no longer just a ship, it was a node. in a global network of power projection that reached back to the Pentagon and out to every satellite in orbit. The geopolitical context of the last decade had led to this exact moment of contact, where diplomacy ended and kinetic reality began. The world was watching, the digital tracks on the screen, waiting to see if the most sophisticated navy in history could hold the line. The transition from modified alert to full combat footing happened in a heartbeat. The ship's general announcing system, the 1MC, blared the call to general quarters with a rhythmic, pulsing tone that cut through the silence of the berthing decks. 330. Sailors and officers moved with a practiced, fluid discipline that was the hallmark of the United States Navy's surface force. Inside the narrow passageways, the air was quickly filled with the sound of heavy boots on steel non-skid flooring and the metallic clatter of watertight hatches being dogged shut. The smell of the ship shifted from the faint aroma of the galley's night rations to the sharp, ozone-tinged scent of high-voltage electronics running at maximum capacity. Within 4 minutes, every station on the destroyer, DDG-87, was manned and ready. In the engineering spaces deep below the waterline, the 4 gas turbine engines were brought to full power, their collective 100,000 horsepower ready to push the 10,000-ton vessel through the water at over 30 knots. The vibration of the hull changed, from a low, rhythmic thrum to a powerful, high-frequency shudder that could be felt in the teeth of every sailor on watch. This was Condition 1, the highest state of readiness, where every weapon system was slave to the Aegis combat suite, and every soul on board was focused on a single objective: survival and mission accomplishment. At the center of the ship sat the Combat Information Center, a windowless vault protected by layers of high-tensile steel and Kevlar armor. It was the brain of the Mason, where the massive streams of data from the ANSPY-6 radar were processed into a coherent tactical picture. The tactical air officer sat at his console, his headset adjusted, communicating in a calm, clipped shorthand with the carrier's airborne early warning assets. There was no shouting, no frantic movement, and no visible fear. The years of repetitive drilling in the simulator had replaced panic with a cold, analytical precision. The commanding officer took his seat in the center of the compartment, his eyes scanning the primary tactical display. To his left, the electronic warfare supervisor monitored the electromagnetic spectrum, looking for any signs that the incoming missiles were attempting to jam the ship's sensors. To his right, the weapons control officer sat with his hand near the firing keys, waiting for the final confirmation of a fire control solution. The room was a symphony of technical jargon and status reports, each one a vital piece of the defensive puzzle being assembled in real time. Surface Track 5012 is confirmed hostile, the electronic warfare supervisor reported. I am seeing active seeker emissions. In the J-band, they are searching for a large radar cross-section. The incoming Iranian missiles were no longer just ballistic projectiles, they were actively hunting. Their internal radars were pinging the surface of the Gulf, looking for the massive signature of the aircraft carrier, or the protective screen of destroyers. The Mason's own electronic countermeasures suite began to fire back, projecting a digital fog of false targets and noise intended to confuse the enemy's primitive seeker heads. The atmosphere in the room was one of total professional immersion. A young second-class petty officer, barely 21 years old, sat at the track readiness console, her fingers moving across the keys with the speed of a professional pianist. She was responsible for maintaining the bridge between the ship's sensors and the standard missile interceptors currently screaming through the atmosphere. If her link wavered for even a second, the interceptors would lose their guidance and the defensive shield would shatter. She didn't look at the clock. She only looked at the vector lines that represented the lives of everyone she knew. The commanding officer glanced at the digital clock on the bulkhead. It had been exactly 3 minutes since the initial launch detection. In the world of modern naval warfare, 3 minutes was an eternity and a heartbeat all at once. The ship was now a fully integrated weapon system, its radars, missiles, engines, and crew operating as a single, lethal organism. The cold air of the Combat Information Center was now heavy, with the collective breath of the team, a tangible reminder of the human element at the core of the high-tech machinery. All interceptors are in the mid-course phase, the weapons control officer announced. The link is solid. Target separation is maintaining at 3 miles between tracks. Intercept point is 60 miles out. Altitude 55,000 feet. The destroyer held its breath. The Mason had done everything according to the book, from the initial detection to the release of the Standard Missile 6 battery. Now, the physics of high-velocity impact would take over, and the professionalism of the crew would be measured by the flashes of light in the sky. The tactical computers on board the destroyer DDG-87 were now processing over 100 million lines of code every second to refine the threat profile of the incoming Salvo. The 4 yellow diamonds on the primary tactical display were no longer generic contacts, as the AN/SPY-6 radar had successfully classified each one based on its ballistic trajectory and infrared signature. 3 of the tracks were identified as Khalij-Far's anti-ship ballistic missiles, a solid fuel system with a range of approximately 300 kilometers and a warhead weighing 1,100 pounds. The 4th track, designated Bravo India 004, was something far more dangerous. A FATA-1 hypersonic maneuverable re-entry vehicle capable of reaching speeds exceeding Mach 5. The recycled air in the Combat Information Center was dry and carried the faint, metallic scent of heated silicon and high-voltage circuit boards running at peak power. Every sailor at a console was focused on the technical reality of the threat, as the missiles had now cleared the dense layers of the atmosphere and were arcing through the vacuum of space. At this altitude, the missiles were no longer burning fuel, but were instead following the cold, predictable laws of orbital mechanics, falling toward their targets with devastating momentum. The Khalij-Far's missiles were designed to use an internal inertial navigation system for the mid-course phase, corrected by satellite data, before activating an electro-optical seeker for the final dive. Track Bravo India 004 is showing non-ballistic behavior, the fire control supervisor reported, his voice cutting through the low hum of the cooling fans. The FATA-1 is executing a skip maneuver at the edge of the atmosphere, attempting to bleed off excess energy and confuse our interceptor's lead point calculation. This was the primary challenge of the hypersonic threat, as the missile did not follow a simple parabola but could instead change its flight path to avoid defensive fire. If the FATA-1 successfully executed its maneuver, it would enter a terminal glide that would bring it in, below the primary radar horizon, leaving the ship with only seconds to respond. The projected impact points for the 3 Khalij-Far's missiles were clustered in a tight box around the coordinates of the aircraft carrier, located 50 miles to the south. The physics of the impact were staggering, as a 1,000-pound warhead traveling at 4,000 feet per second carried enough kinetic energy to punch through multiple decks of armored steel. Even a near miss would generate a massive shockwave capable of rupturing fuel lines and shattering sensitive radar arrays on the carrier's superstructure. The Mason's crew knew that their 4 Standard Missile 6 interceptors were currently the only thing standing between the carrier and a catastrophic mission kill. The threat cone is expanding, the tactical air officer announced, as the computers calculated the possible maneuvering envelope of the hypersonic contact. If we don't achieve a kinetic kill in the next 30 seconds, the FATA-1 will enter its terminal high-alpha maneuver, and we will lose the tracking solution. The technical breakdown was clear. The Iranian missiles were not just projectiles, but sophisticated hunters that were actively trying to outsmart the Aegis combat system. The Iranian engineers had designed these weapons to exploit the tiny gaps in traditional radar coverage, forcing the American defenders to rely on the absolute limit of their technology. The screen flickered as the AN/SPY-6 radar transitioned from search mode to high-resolution track and dwell, focusing all of its energy on the 4 incoming threats. The resolution was now high enough that the operators could see the missile's fins adjusting in real time as they interacted with the thin air of the upper atmosphere. The heat generated by the friction of the air was causing the nose cones of the missiles to glow with temperatures exceeding 2,000 degrees, creating a plasma sheath that was visible to infrared sensors. This heat signature was the fingerprint, the Mason was using to guide its own interceptors toward a collision point 40 miles above the surface of the sea. In the engineering spaces, the crew monitored the power draw from the massive radar arrays, ensuring that the electrical grid remained stable under the extreme load. The ship was literally vibrating, with the sheer volume of data being processed and the electromagnetic energy being projected into the night sky. Outside, the Gulf remained black and indifferent, but in the digital realm, a war of mathematics and high-speed physics was being fought with absolute intensity. The threat profile was fully established, the targets were locked, and the final seconds of the mid-course phase were ticking away. The coordination between the USS Mason and the broader regional defense network was a masterpiece of digital architecture. 200 miles to the south, an E-2 Delta Hawkeye circled at 35,000 feet, its massive radar dome rotating slowly as it fused data from half a dozen sources. The Hawkeye was the quarterback of the engagement, providing the engage on remote data that allowed the Mason to fire at targets still below its own radar horizon. In the Combined Air Operations Center at Al Udeid Air Base in Qatar, officers from the United States Air Force watched the same blue and yellow icons, their consoles linked by a satellite network that spanned the entire globe. The air was filled with the low, constant drone of server racks, and the focused murmur of controllers maintaining the integrity of the kill chain. The commanding officer of the Mason adjusted his headset, listening to the final confirmation from the theater commander. The rules of engagement were clear, and any ballistic threat headed toward a United States Navy vessel or a partner nation's sovereign territory was to be neutralized with extreme prejudice. The authorization to engage the hypersonic threat, the Fatah 1, was granted in a single, coded burst of text that appeared on the captain's primary glass. There was no room for hesitation. The closing speed between the interceptors and the targets was now over 10,000 miles per hour, a velocity that shrunk the decision window to the width of a human breath. The tactical air officer reported that the Standard Missile 6 interceptors were transitioning to their terminal phase. Seekers are active. Track Bravo India 001 is locked. Track 002 is locked. We have a high-confidence solution on the hypersonic maneuverable vehicle. Inside the nose of each interceptor, a miniaturized active radar seeker roared to life, searching the blackness of the upper atmosphere for the searing heat of the incoming warheads. The missiles were no longer receiving guidance from the ship. They were now independent hunters, their internal computers making micro-adjustments to their flight surfaces every millisecond. The trigger was squeezed in the digital sense, the Aegis system committing to the final intercept geometry. The first Standard Missile 6 shrieked through the thin air of the mesosphere, its solid rocket motor spent. Now a 10-foot dart of high-strength alloy moving at 4 times the speed of sound. The heat blast of the friction had turned the leading edges of the interceptor into a glowing white line, and the chemical bite of the cooling systems struggled to keep the internal electronics from melting. There was no explosive warhead on the interceptor. It was a hit-to-kill weapon designed to destroy the target through the sheer application of kinetic energy, the equivalent of a freight train hitting a brick wall. The impact was a silent, blinding flash 55 miles above the surface of the Persian Gulf. The first Standard Missile 6 punched straight into the center of the Khalij Fars warhead, the two objects colliding with a combined energy that turned solid steel into a cloud of incandescent plasma instantly. The Iranian missile did not just explode. It ceased to exist as a coherent object. Its half-ton warhead shattered into a million fragments of molten metal that were sent flying across a 5-mile radius. The second and third intercepts followed in a rhythmic succession of white light. 2 more Iranian missiles pulverized by the relentless accuracy of the American defense. The fourth target, the Fatah 1 hypersonic vehicle, attempted a final desperate maneuver. It pitched its nose down, trying to use the increasing density of the atmosphere to skip away from the incoming fire. But the Standard Missile 6 was faster and more agile, its side thrusters firing in short, violent bursts that snapped the interceptor onto the new intercept vector. The warhead of the Fatah 1 erupted in a massive fireball as the interceptor drove into its side, the hypersonic vehicle's structure failing under the immense stress of the collision. The aerodynamic forces at Mach 5 did the rest, tearing the remains of the missile apart and scattering them across the upper atmosphere like a trail of dying embers. The immediate aftermath was a haunting silence on the radar screens of the USS Mason. Where there had been 4 lethal, aggressive threats, there was now only an expanding cloud of debris, a rain of titanium and aluminum, that would burn up harmlessly before it ever reached the water. The black sky over the Gulf, once torn apart by streaks of white exhaust and the glare of explosions, returned to its natural stillness. Inside the Combat Information Center, the radar operator stared at his screen for 3 full seconds, waiting for a ghost or a leaker to appear, but the sky was empty. All tracks neutralized, the tactical air officer announced, his voice finally betraying a hint of the pressure he had been under, confirming 4 kinetic kills. No secondary contacts detected. The shield is holding. The cold, dry air of the compartment seemed to relax, though no one left their station. The smell of sweat and recycled oxygen was heavy, a human contrast to the cold perfection of the machines that had just saved the ship. The battle of the upper atmosphere was over, but the destroyer remained at general quarters, its sensors already searching for the next move in a game that was far from finished. 4 o'clock in the morning. The radar horizon of the USS Mason. The high-altitude interception of the ballistic Salvo had been a success, but the tactical picture was far from clear. Passive acoustic sensors and low-light cameras on the bridge wings suddenly picked up a new, more immediate threat, a swarm of low-flying cruise missiles and suicide drones launched from mobile coastal batteries to exploit the radar clutter of the waves. The air was thick with the smell of burnt powder and the heavy, electric scent of the ship's cooling systems working at maximum capacity. 10 yellow icons blossomed on the tactical displays, moving at 500 miles per hour and skimming just 20 feet above the dark, choppy surface of the Gulf. These were Nor cruise missiles, based on the Chinese SAT-102 design, utilizing a turbojet engine and an active radar seeker for the terminal phase. Because they were flying so low, they remained hidden by the curvature of the Earth until they were less than 22 miles from the destroyer. The time to impact was now less than 3 minutes. The Aegis system immediately prioritized the targets, slaving the forward and aft Mark 41 vertical launch systems to a new defensive geometry designed for high-density, low-altitude saturation. Inside the Combat Information Center, the tone of the engagement shifted from the clinical math of ballistic intercept to the frantic, high-speed reality of close-in defense. We have multiple leakers, designated surface tracks 6001 through 6010, the tactical air officer reported, requesting permission to engage with the Evolved Sea Sparrow missile battery and the rolling airframe missile launcher. The commanding officer gave the order, without looking away from the screen. Weapons free. Engage all tracks in the priority order. The trigger was squeezed. The Evolved Sea Sparrow missile shrieked, off the forward rail, a white column of fire punching backward through the lingering smoke of the previous launch. The heat blast washed across, the faces of the sailors standing nearest to the bridge windows, a searing wave of 3,000 degrees that bleached the darkness white for a split second. The smoke rose in a dense white column that blotted out the horizon for 3 full seconds, and the sound of the ignition was a physical blow that compressed every chest in the compartment. The first Evolved Sea Sparrow missile traveled at Mach 3, its proximity fuse active. 2 miles from the ship, the warhead detonated with a high-explosive fragmentation blast. The warhead punched clean through the nose cone of the lead Nor missile, shredding the internal electronics and detonating the fuel cell stored in the midsection. A fireball erupted instantly, a violent orange sphere that turned the target into 1,000 pieces of burning debris. The remaining cruise missiles in the formation reacted, their internal logic processors detecting the loss of their leader and attempting to break into a wider pincer maneuver to flank the destroyer. One of the secondary cruise missiles took a direct hit from a second interceptor, its structure failing as the blast wave threw the missile into a terminal tumble. The wreckage was sent flying across the surface of the water, skipping like a flat stone before it finally vanished into a white geyser of spray and steam. The fire from the explosion was so intense that it was briefly visible on the ship's infrared cameras as a white-hot bloom that saturated the sensors. Black smoke rose from the wreckage still, settling into the sea, marking the graveyard of the first 4 cruise missiles. The burning pieces were still above water when the radio channels of the enemy formation's command link went silent for exactly 3 seconds, then erupted in overlapping voices of automated telemetry. The remaining 6 targets were now less than 8 miles away, accelerating into their final terminal dash. The ship's hull shuddered under the vibration of the engines and the rapid-fire cycling of the defensive systems. The second-class petty officer at the weapons console didn't blink. She was already tracking the remaining 6 threats, assigning each one to a specific defensive layer. ESSM battery is empty on the forward deck. Transitioning to the aft launcher. Rolling airframe missile is in standby. I have a lock on the remaining drone swarm. The professional discipline of the crew was the only thing preventing the chaos of the incoming swarm from turning into a disaster. The air around the ship was now a chaotic swirl of missile exhaust, salt spray, and the acrid stink of chemical propellant. The sky was no longer black, but was instead a tapestry of white streaks and red flashes, as the destroyer fought to maintain its perimeter. Every system on the ship was being pushed to its mechanical limit, and every sailor was a witness to the raw power of modern naval combat. The second wave had been thinned, but the most dangerous phase of the engagement, the close-in defense, was just beginning. 4 o'clock and 5 minutes in the morning. The Persian Gulf. The 6 remaining targets were now less than 5 miles from the destroyer USS Mason. The air over the aft deck was a swirling vortex of hot exhaust and the cold stinging spray of the sea. On the starboard side, the RIM-116 rolling airframe missile launcher began to rotate. It moved with a sudden, jerky precision, its 21 launch tubes pointing toward the horizon. The targets were a mixture of 3 Nor cruise missiles and 3 smaller, slower Shahed-class suicide drones. This was the inner tier of the ship's defensive umbrella, where the margin for error was measured in milliseconds. The rolling airframe missile was a specialized tool for this exact moment. It used a dual-mode seeker that listened for the radar emissions of the incoming cruise missiles while looking for their heat signatures. Unlike the larger standard missiles, the rolling airframe missile was a fire-and-forget weapon. Once it left the tube, the ship's computers no longer needed to provide guidance. The missile itself would do the math, spinning at high speed to maintain its flight stability as it closed the distance. The launcher, designated the Mk-49, was a compact, high-speed system designed specifically for high-stress saturation attacks. Aft launcher is tracking. Targets are within the engagement envelope, the weapons control officer announced. The interior of the Combat Information Center was now humming with a different frequency of energy. The tactical displays showed the 6 red dots closing the gap with terrifying speed. The destroyer was currently executing a hard turn to port, heeling over at a 15-degree angle. This maneuver was intended to unmask the aft launchers, giving them a clear line of sight to the incoming threats. The deck plates groaned under the stress of the turn, and the smell of hydraulic fluid was faint but present. The command was given to fire, in salvo mode. 3 RIM-116 missiles were launched in a sequence that lasted less than 2 seconds. The sound of the launches was a series of sharp, high-pitched cracks that echoed through the ship's superstructure. Unlike the deep roar of the standard missiles, these interceptors sounded like a giant whip cracking against the air. The streaks of white light they left behind were thin and jagged, zigzagging as the missiles made their final corrections. The salt-heavy air was momentarily illuminated, revealing the white caps of the Gulf in sharp, flickering detail. The first interceptor found its target 3 miles out. The warhead detonated in a shower of white-hot tungsten pellets that shredded the incoming Nor missile. The cruise missile didn't explode immediately, but its flight surfaces were destroyed, causing it to cartwheel into the water. A second later, 2 of the Shahed drones were obliterated in a single overlapping blast. The fiberglass and plastic structures of the drones offered no protection against the explosive force of the interceptors. The 10 men's remains of the drones fell into the sea like burning confetti, extinguished almost instantly by the dark water. 3 confirmed kills. 3 targets remain, the radar operator called out. The tension in the room was a physical weight, as the remaining 3 threats were now inside 2 miles. 1 Nor missile and 2 drones were still coming, and they had separated to attack from different bearings. This was a classic starburst maneuver, designed to force the ship's defensive systems to divide their attention. The aft rolling airframe missile launcher pivoted again, searching for the next lock-on. The ship's internal alarm for a vampire, inbound, a hostile missile, continued its steady, rhythmic pulse. On the bridge, the commanding officer watched the infrared feed on a secondary monitor. He could see the heat bloom of the final Nor missile, glowing white, against the cold black of the ocean. Keep the turn coming. Don't let them get a clean look. At our broadside, he ordered. The helmsman gripped the controls, his knuckles white, as he fought to keep the 10,000-ton ship on its precise heading. The vibrations from the 4 gas turbine engines were now a constant, bone-shaking presence. Every sailor on the bridge was wearing their flash gear, the fire-resistant hoods and gloves, a reminder of the danger. The final RIM-116 left the launcher with a sudden burst of flame. It chased the Nor missile through a series of violent, high-G maneuvers just 10 feet above the water. The interceptor slammed into the tail section of the cruise missile, the impact sending a massive geyser of water into the air. The debris from the explosion was sucked into the wake of the destroyer, leaving only a fading, oily slick behind. But the 2 remaining drones were now so close that the missile launchers could no longer depress low enough to hit them. The defense of the USS Mason was about to transition to its final, most violent layer. 4:07 in the morning. The forward deck of the USS Mason. The 2 remaining Shahed drones were now less than 1,500 yards away, their lawnmower-like engines audible over the rush of the wind and the hum of the ship. The close-in weapon system, a white domed mount shaped like a large capsule, swiveled with a sudden, violent twitch. Its search radar had already handed off the tracking data to the engagement radar, which was now locked onto the lead drone's low-profile fuselage. The air surrounding the mount was heavy, with the smell of ozone and the cold, damp mist of the Persian Gulf. Inside the Combat Information Center, the technicians watched the video feed as the crosshairs of the optical sensor snapped onto the target and held with unwavering precision. The close-in weapon system was the final layer of the military defensive shield, a completely autonomous 20mm multi-barrel point defense system capable of firing 75 rounds every single second. It did not use missiles, but instead created a wall of tungsten-cored ammunition that shredded anything in its path. The system was designed to operate as a robotic sentry, making the final decision to fire in a fraction of a second when all other defenses had been bypassed. The mount, designated Mark 15, was vibrating with the internal rotation of its 6 barrels, which were now spinning at their maximum operational speed. The trigger was squeezed by the automated fire control logic. The multi-barrel point defense system erupted with a sound that was not a series of shots, but a continuous, earth-shaking buzz that sounded like a giant zipper being torn open. A stream of white-hot tracer fire reached out. Across the water, a solid line of light that seemed to connect the ship directly to the incoming threat. The heat blast from the muzzle flashed against the gray steel of the forward superstructure, and the deck beneath the mount shuddered with the recoil of 4,500 rounds per minute. The 20mm rounds punched through the fiberglass wings and the plastic fuel tank of the first unidentified drone. The heavy tungsten penetrators moving at 3,000 feet per second. The drone did not simply catch fire. It was ground, apart by the sheer volume of metal hitting it simultaneously. The wings were severed instantly, sent flying into the dark air, and the main body of the drone disintegrated into a cloud of shrapnel and unburnt fuel. A small, oily fireball erupted for a fraction of a second before the wreckage was slammed into the surface of the sea by its own momentum. The close-in weapon system did not pause. For a heartbeat, its sensors already slewing the barrels toward the final target approaching from the port side. The second drone attempted to dive, hoping to use the sea spray to mask its thermal signature, but the radar-guided gun was faster than any human pilot. Another violent burst of fire tore through the night, the tracers carving a bright arc through the humid air. The second drone was bludgeoned out of the sky, its engine block shattered, and its guidance system pulverized before it could reach the 500-yard mark. Dead silence followed. The final burst of the gun. The only sound was the high-pitched whine of the barrels spinning down and the mechanical clatter of thousands of spent brass shell casings hitting the deck plates. The air was thick with the acrid, choking stink of burnt gunpowder, and the smell of hot metal cooling rapidly in the sea breeze. Smoke curled from the muzzle of the gun, rising in, a thin gray ribbon that was quickly carried away by the wind. Inside the Combat Information Center, the primary tactical display finally showed a clear screen. The 10 red icons of the cruise missile and drone swarm had been replaced by a series of blue markers, indicating where the debris had hit the water. The shift supervisor took a deep breath, the first one he had allowed himself in, nearly 10 minutes. He looked at the commanding officer, who was still standing at the center of the room, his eyes fixed on the empty radar horizon. All threats neutralized, the tactical air officer reported, his voice echoing in the quiet compartment. Forward and aft. Close-in weapon systems are in standby. No impacts detected on the hull. The high-value asset reports a clean sensor sweep. The Mason had survived the multi-layered assault. From the hypersonic ballistic missiles in the upper atmosphere to the low-flying suicide drones at the water's edge. The crew remained at their stations. The adrenaline still high, but the immediate crisis of the saturation attack had passed. The ship, though depleted of its primary interceptors, remained a potent and defiant presence in the dark waters of the Gulf. 4:15 in the morning. The forward and aft decks of the destroyer DDG-87. The smoke from the last interceptor was still clearing, but the mechanical reality of the engagement was written in the empty, blackened steel cells of the Mark 41 vertical launch system. The USS Mason had successfully defended the strike group, but the cost of that defense was measured in a significant depletion of its primary magazine. The air over the deck was a heavy mix of humid Gulf heat and the lingering acrid stench of solid rocket propellant that had baked onto the vertical launch hatches. Below the non-skid surface, the weapons department was already beginning the grim tally of what remained in the ship's arsenal. The Mark 41 vertical launch system was the heart of the destroyer's offensive and defensive power, consisting of 96 individual cells. In the span of less than 15 minutes, the USS Mason had expended 4 Standard Missile 6 interceptors, 12 Evolved Sea Sparrow missiles, and 5 rolling airframe missiles. While the ship still possessed a formidable array of Tomahawk cruise missiles and anti-submarine rockets, its specialized shield against high-end ballistic and hypersonic threats had been cut by nearly 40%. This was the reality of the magazine depth problem. A modern high-intensity conflict could exhaust a billion-dollar warship's primary ammunition in a single watch. Inside the Combat Information Center, the weapons officer presented the status report to the commanding officer. "Captain, we are green on sensors and propulsion, but we are Winchester on the forward Standard Missile 6 bank," the officer reported, using the military brevity code for depleted ammunition. "We have enough for one more saturation attack of this scale. But if the, quote, Islamic Revolutionary Guard Corps launches a third wave, we will be forced to rely entirely on the close-in weapon systems and soft-kill decoys." The commanding officer nodded, his face illuminated by the blue glow of the tactical map showing the USS Mason at coordinates 26 degrees north, 54 degrees east. The logistics of rearming an Aegis destroyer were among the most complex challenges facing the United States Navy. Unlike the deck guns of the past, the vertical launch cells could not be easily reloaded at sea in anything other than absolute calm, and even then, the process was dangerous and slow. To restore its full combat capability, the Mason would eventually need to pull into a secure port like Naval Support Activity Bahrain or meet a specialized crane-equipped tender in a protected anchorage. However, with the Strait of Hormuz contested, a trip to port meant leaving the carrier strike group without one of its most capable escorts. Strategic coordination was already underway at the 5th Fleet headquarters. The Combat Logistics Force was moving to support the destroyer, with the supply ship USNS Arctic being vectored toward a rendezvous point 60 miles south of the Mason's current position. The USNS Arctic carried thousands of tons of fuel and stores, but more importantly, it carried the replacement canisters for the Evolved Sea Sparrow and rolling airframe systems. The plan was to conduct an underway replenishment at sunrise, a high-stakes maneuver where two ships would steam side by side at 15 knots, separated by only a few dozen yards of churning water, while transferring fuel and palletized munitions. The human cost of the logistics chain was also becoming apparent. The ordnance handling teams, the G1 Division sailors, were already on deck in their red jerseys, inspecting the launch seals for heat damage and preparing the cranes. They were exhausted, having been at general quarters for hours, but the adrenaline of the combat remained. The smell of diesel fuel from the ship's service generators hung heavy in the air as the Mason increased speed to 30 knots, racing toward the rendezvous point before the sun could rise and expose them to further aerial observation. The executive officer walked the length of the ship, checking in with the damage control teams and the engineering department. He noted the high-temperature blistering on the paint of the forward deck, a physical scar from the heat of the standard missile launches. The machinery held up, the chief engineer reported, wiping grease from his forehead. But the cooling pumps for the AN/SPY-6 radar have been running at 110% capacity for the last hour. We need to cycle them down for maintenance as soon as we clear the threat sector. Every system on the ship, from the silicon chips to the steel turbines, had been pushed to its design limit. As the first hint of gray light began to touch the eastern horizon, the USS Mason remained a lethal but wounded predator. The defense of the carrier had been a tactical masterpiece, but the strategic burden of maintaining that defense was now a race against time and supply lines. The commander of Carrier Strike Group 2 had already ordered a second destroyer, the USS Halsey, to move north to bolster the Mason's position. In the modern theater of war, victory was not just about who fired the first shot, but about who could sustain the fire when the magazines began to run dry. 5:30 in the morning. The horizon over the Iranian coast was a jagged, bruised line of orange and deep violet light. The USS Mason remained at a modified state of general quarters, but the immediate violence of the engagement had been replaced by the clinical, high-stakes work of the battle damage assessment. The air on the bridge was cool, but the heavy scent of ozone from the electronics and the faint, lingering smell of saltwater spray hung in the still air. High above the Gulf, the E-2 Delta Hawkeye continued its slow, orbiting patrol, its radar fusing millions of data points to confirm that the sky was truly empty of threats. The battle damage assessment was the final, mandatory step in the kill chain. A process designed to ensure that no ghosts or disabled, but still dangerous targets, remained in the battle space. The primary source for the assessment was the AN/SPY-6 radar suite, which had recorded every millisecond of the engagement. The tactical computers on the destroyer were now replaying the high-resolution tracks of the 14 intercepted targets, comparing the predicted intercept points with actual debris signatures recorded at the moment of impact. When a Standard Missile 6 or an Evolved Sea Sparrow struck a target, it created a unique electromagnetic fingerprint, a sudden, massive expansion of the radar cross-section, followed by a rapid fragmentation into hundreds of smaller, decelerating contacts. The software confirmed that all 4 of the ballistic targets, including the Fata-1 hypersonic vehicle, had undergone total structural failure, at altitudes exceeding 40,000 feet. To provide secondary confirmation, the 5th Fleet Headquarters accessed data from the space-based infrared system satellites. These satellites, positioned in geostationary orbit, had monitored the entire event from the initial thermal bloom at the launch sites near Bandar Abbas. The satellite data showed the 4 launch plumes, followed by the 4 distinct flashbang signatures of the kinetic interceptions in the upper atmosphere. Crucially, the satellites reported no secondary thermal events on the surface of the water near the carrier strike group. This negative reporting was the most vital piece of evidence. It proved that no Iranian warheads had reached their intended targets, and that no American ships had sustained even minor damage. At coordinates 26 degrees 10 minutes north, 54 degrees 15 minutes east, the USS Mason detected a large debris field on its surface search radar. This was the splash point for the 6 Nor cruise missiles and the Shahed drones that had been destroyed in the final phases of the attack. The radar showed a cluster of hundreds of small, stationary returns where the wreckage was still bobbing on the surface of the relatively calm Gulf waters. The commanding officer ordered a high-resolution optical scan of the area, using the ship's multispectral targeting system. On the main screen in the Combat Information Center, the infrared camera zoomed in. On a floating section of a Nor missile wing, the honeycomb structure clearly visible before it sank beneath the waves. The final tally of the engagement was recorded in the ship's tactical log with professional brevity. 4 ballistic missiles launched, 4 destroyed. 10 cruise missiles and drones launched, 10 destroyed. The USS Mason reported 0 casualties among its 330 crew members. The hull remained intact, with no evidence of fragmentation damage or near-miss shock trauma to the sensitive sonar dome located in the bulbous bow. The aircraft carrier, the primary target of the Iranian Salvo, reported that its own sensor suites were fully operational and that its flight deck was ready to resume launch and recovery operations at sunrise. Despite the success, the tactical air officer noted a concerning detail in the post-mission analysis. The Fata-1 track showed a higher degree of maneuverability in the terminal phase than we predicted in the pre-mission briefing, he stated. His voice recorded for the official after-action report. The Standard Missile 6 interceptor achieved the kill at the absolute limit of its engagement envelope. If the target had initiated its high-alpha maneuver 2 seconds earlier, the intercept geometry would have failed. This was the reality of the technological arms race. Every successful defense provided the enemy with data on how to improve their next attack. The win was decisive, but it was also a warning that the window of military technological superiority was being challenged by new, faster threats. In the engineering spaces, the Black Shoes, the ship's engineers, conducted their own assessment of the mechanical systems. The 4 General Electric LM2500 gas turbines had performed flawlessly, but the high power draw from the radar arrays had caused a minor coolant leak in the number 2 electrical generator. The team worked in the percent-tensive press, 90-degree heat of the engine room, their coveralls soaked in sweat, to bypass the damaged line. It was a small price to pay for the survival of the ship, but it was a reminder that even a perfect defense put an immense strain on the physical structure of the vessel. As the sun finally cleared the horizon, the USS Mason was no longer shrouded in the darkness of the night. The gray steel of the destroyer gleamed in the early light, looking remarkably untouched given the violence it had just unleashed. The battle damage assessment was complete. The shield had held, the enemy had been blinded, and the strike group remained the dominant force in the region. The commanding officer took a final look at the clear tactical screen before ordering the ship to transition to Condition 2. The immediate battle was over, but the strategic assessment of what this escalation meant for the next 24 hours was only just beginning. 6:15 in the morning. The Persian Gulf. The USS Mason began the slow transition from general quarters to a modified alert posture known as Condition 2. Inside the ship, the 330 sailors who had spent the last 2 hours at the edge of life and death finally felt the weight of exhaustion. The air in the mess decks was thick with the smell of strong coffee and the first batches of scrambled eggs being prepared for the morning watch. There was no cheering or celebratory shouting. The culture of the United States Navy was one of quiet, professional satisfaction in a job executed according to the manual. On the bridge, the helmsman and the lee helmsman switched out with their reliefs, their hands finally relaxing from the grips of the steering console. The commanding officer remained in his chair, his eyes red-rimmed from lack of sleep, but his posture still upright and disciplined. He looked out over the bow at the flat, gray-blue water of the Gulf, which showed no trace of the violence that had occurred only 90 minutes earlier. To his left, the junior officer of the deck was updating the digital log, recording the exact times and coordinates of every missile launch and intercept. Below decks, in the berthing areas, sailors sat on their racks and pulled off their flash hoods and gloves, their faces marked by the indentations of their gas masks. A 20-year-old sonar technician from Ohio stared at his hands, which were still slightly shaking from the task, adrenaline of tracking the incoming threats. He had been responsible for monitoring the underwater sensors for any sign of submarine activity, while the missiles were screaming overhead. His world for the last hour had been a dark room and a glowing green screen, but he knew his part had been vital to the ship's survival. The professional reaction of the crew was a testament to the thousands of hours of training they had undergone before ever leaving their home port. Every fire drill, every missile simulation, and every late-night engineering exercise had prepared them for the 15 minutes that mattered most. The bond between the sailors was not spoken aloud, but it was visible in the way they moved around each other in the narrow passageways. They were no longer just a collection of individuals from across the United States. They were a single, integrated team that had held the line. In the galley, the culinary specialists worked double shifts to ensure that every member of the crew received a hot meal before catching a few hours of sleep. The sound of metal trays clattering and the low murmur of conversation replaced the rhythmic pulse of the combat alarms. One sailor, an electronics technician, leaned against a bulkhead and closed his eyes for a moment, the heat of the coffee cup warming his palms. He thought about his family in Virginia, who were still asleep, unaware that their son had just participated in one of the most complex naval engagements of the century. The ship continued its steady course toward the rendezvous with the supply vessel, the USNS Arctic, at a speed of 25 knots. The morning sun was now fully above the horizon, bleaching the sky a pale, hazy blue that was common in the high humidity environment of the Gulf. The USS Mason looked identical to the way it had appeared the day before, but the crew knew that everything had changed in the darkness. They had been tested by a near-peer threat, and had proven that the shield of the United States Navy was as strong as the steel it was built from. The commanding officer stood up and walked to the bridge wing, taking a deep breath of the salt-laden air. He watched a pair of seagulls circling the wake of the ship, seemingly indifferent to the technology and the geopolitics that govern the waters below. The crew was tired, the magazines were low, and the mission was far from over, but for this moment, there was peace. The human element had met the machine, and in the crucible of combat, the human element had prevailed. 7 in the morning. The Persian Gulf, 60 miles south of the previous engagement zone. USS Mason was already positioned alongside the supply ship USNS Arctic, the two massive vessels moving in a precise, parallel formation at 15 knots. The morning sun was a pale white disk hanging in a sky thick with the haze of heat, and hanging dust from the Arabian Peninsula. Between the ships, heavy nylon fuel lines and high-tension steel cables stretched across the churning gap of green water. The air was filled with the rhythmic clatter of pneumatic winches and the shouting of boatswains' mates coordinating the transfer of palletized munitions and stores. The strategic aftermath of the engagement on the 14th of April, 2026, was being analyzed at the highest levels of the United States government. The successful interception of the 14-missile Salvo had fundamentally altered the tactical calculus in the Middle East. By neutralizing the Fatah-1 hypersonic vehicle, the USS Mason had proven that the Aegis combat system and the Standard Missile-6 were capable of defeating the most advanced threats in the foreign military inventory. The message sent to the military patrol boats was clear. The window of vulnerability they sought to exploit had been slammed shut by armed personnel technical proficiency. The final after-action report for Carrier Strike Group 2 provided a detailed breakdown of the engagement and its costs. United States forces had achieved every strategic objective, maintaining the freedom of navigation in the Strait of Hormuz and protecting the high-value assets of the fleet. The report confirmed the destruction of 4 ballistic missiles, 6 cruise missiles, and 4 suicide drones, with 0 leakers reaching the inner screen. Casualties for the military forces were listed as 0 personnel killed or wounded in action, with no damage reported to any vessel in the formation. However, the report was honest about the severe cost and the strain placed on the logistics chain. The total expenditure of defensive ordnance during the Sabirity 12-minute engagement was calculated at $72 million. The naval warship had depleted a significant portion of its specialized interceptor magazine, requiring an immediate and complex replenishment at sea to remain mission-capable. Furthermore, the high-intensity operation of the radar suite had identified a thermal stress issue in the cooling arrays that would require a 48-hour maintenance window once the ship returned to port. The victory was decisive, but it was a reminder that maintaining a global maritime shield required constant investment and industrial support. In Defense Headquarters Facility, the Secretary of Defense used the success of the naval warship to advocate for increased production of the Standard Missile-6 and the Evolved Sea Sparrow blocks. The engagement had proven that magazine depth was the most critical factor in modern naval warfare, as a single saturation attack could nearly empty a destroyer's primary cells. Across the globe, Allied navies in the Pacific and Europe watched the telemetry data with intense interest, looking for lessons to apply to their own defensive postures. The strategic region remained a flashpoint, but for the moment, the threat of a hypersonic breakthrough had been neutralized by the sailors of the military forces. By noon, the naval warship had completed its replenishment and detached from the supply ship, turning its bow back toward the north. The crew had transitioned to a standard watch rotation, allowing those who had fought through the night to finally find a few hours of deep, dreamless sleep. The deck was clean of spent shell casings, and the launch hatches of the Mark 41 system had been reset and inspected. The ship looked once again like a silent, gray ghost against the shimmering horizon of the sea. The commanding officer stood on the bridge wing one last time before heading to his cabin for a brief rest. He looked toward the foreign military coast, where the silent batteries that had launched the attack were likely being repositioned or rearmed. The cycle of escalation had paused, but the underlying tensions remained as hot and heavy as the regional air. The naval warship would remain on station, a 10,000-ton testament to the resolve of the military forces and the professional discipline of its crew. The shield had held, the carrier was safe, and the mission continued into the coming night.